Hi, this is Iman from Hyderabad. Now I'm going to explain about homework 5 documentation. The question given is like prefix tree, prefix trie. So this is the command line I have used for the execution. So the first question is asked is like for each of 36 data set, what are the size of the trie nodes? So that size of the like for 5,000 is like there is 144,131, and for size of 50,000 is 898,227. For 1 lakh is 1209879, and for 1 million is 1385630. And they're also asking like what is the pattern you observe here as the number of nodes in the trie increases as the number of sequence increases. If the sequence is like increasing 5,000, 50,000, and these tries are also increasing. That's the pattern. And second question is iterating through all the possible 36 matches in the segment, using each to search tab as the prefix try up to one mismatch. How many of you 36 matches had a match? So here is like matches for 5,000 is 136, 50,000 is like 920, for 1 lakh. For 1 lakh is 1178, and for 1 million is 1371. Here they're asked, does it make sense? Explain. Yes, of course it makes sense because the number of matches rises with the number of sequences. So here the large set of 36 matches that involves a higher chance of obtaining match even if up to one mismatch is allowed. So here is the screenshot which I have attached mm, of the size and the matches. And here comes the part B. This is the command I have used for the part B. So here it is also asked for each of the 36 mark data set, what are the sizes of the trie? So here for size of like size for 5,000 is 149,778, for 50,000 is 130,1273. For 1 lakh is like 2368735, or 1 million is 16128,089. Here it is asked like explain the difference between the trie sizes in part A and part B. The difference I observed is like size of the tries in part B are greater than when compared to part A. So and it's also asked like about matches. So it for 5,000 is 33, for 50,000 is 314, for 1 lakh is 515, and for million is 1363. So here it is asked make it sense. Does it make sense? It explains why. Yeah, of course it makes sense. Part B has less matches when compared to part A for number of sequences, but not for large data sets. So maybe like when compared probably because of the data different tries are constructed differently. So yeah, that's it. This is my screenshot for the part B. I'm going to explain my code. Yeah, this is my .h file. These are my header files. So this is like a structure of the prefix trie. Here this ACGT are taken because we know from first we are taking that this is that helper function for mapping a character to the index, and this is like fuzzy match is like for performing fuzzy search with up to one mismatch. And here we have taken private, this here we have taken fuzzy search helper. This is the helper function for fuzzy search. And here comes, this is a default constructor as asked to like take in the question. And this is the constructor to build trie from a set of queries. This is like a destructor. As we know, we should clean up the memory for cleaning up the resources. And this is for function for inserting the into the trie. And this is the like get node count is like function for getting the number of nodes. And this is for searching the sequences. So to perform a fuzzy search with up to one mismatch. And this is like global variables. Yeah, that's all. And this is my main.cpp files, and these are all my header files. As you know, this is the function. This is the function used to read the segment from the given genome file. This is all that. And when comes here, this is the helper function for the generating random base, which is get random base. And also this introduce mutations is like for introducing errors in the sequence. And I have this function for generating like generate sequence with errors, for generating the random sequence with errors. All this I have taken here. And also one more is like for generating random sequence from the segment. This is like with errors, and this is like from segment. And this is a function to insert sequences into a trie. And this is like for processing, yeah, print results, right? So this is a function for processing and printing the results. And this is for executing part A, and this is for part B. And the differences here for part A and part B are like, for part A, like sizes for as the sequence is increasing, size of all the nodes are increasing, you know. For part B, it is increasing when compared to part A. But when comes to matches that hits, that are decreased when compared to part A. So this is the pattern for different parts, pattern handler for different parts. All this is, that's it. And when comes here, this is like all the global variables with initialization. We need 5,000. I mean 5,050K and 1 lakh and 1 million. And this is like for mapping the character to index. I told you like in .h file. And this is the default constructor we used here. And this is the constructor to build a trie from a set of sequences. And we know after constructing the destructor is important for cleaning up the resources. This is to insert a word into a trie. And this is for getting the number of nodes in the trie. And this is fuzzy search. This is for with up to one mismatch we can search. And this is also same, up to one mismatch. And this is the helper function for deleting nodes. Here is like what we can say is like, here I can find that optimization. Here is like original implementation is like a recursive approach was used for clearing the trie nodes, which could lead to stack overflow for large tries. But the optimization here is like switch to queue based like BFS approach for to iteratively clear the nodes. This avoids the risk of stack overflow and ensure efficiency for memory cleanup. That what I have done here. And this is also helper function for fuzzy search. And this is my make file. Here I have given the target. So with this I have done the execution. Yeah, that's it. And if I want to say about like specific bugs that are like encountered are issues like memory leaks. Memory management is a thing. It is like memory leaks due to improper deletion of dynamically allocated memory. But by implementing a proper cleanup in the destructor of a genome trie and ensure delete, that is like dynamically allocated the arrays. Thank you. Thanks for listening.